A dive, as I said. We took out the deep to shorten it, but it really didn't help. Into the history of disaggregating operating systems from hardware, from IBM PC DOS to MS-DOS, from Unix to Linux. Once upon a time, we had closed systems. We still have them today, but they were predominant. And there was an evolution then into desktop, server, and network operating systems as the different needs arose and evolved. And the desktop predominantly closed still today, but also predominantly less part of the market as the new generation moves mobile. Server was effectively closed until the early 80s with the rise of BSD and later Linux. And network operating systems, again, closed until the rise of BSD and later Linux. This is a very brave topic for me to cover because back in the 80s and 90s, the very mention of, where was the start of anything would bring on a massive fight and a flaming war on, email chat groups and, yeah. Oops, we dare not. So as we go in and look and discuss this, and believe this is my personal perspective, so you can't argue with me, because it's what I feel. And we all know that feelings today are more important than arguments. Okay? But remember that we are standing on the shoulders of giants. As Isaac Newton said, if I see further, it is only because I am standing on the shoulder of giants. I'll show the next image just briefly. This one is sort of the Unix ecosystem, and this one, the Microsoft system. I showed you the second slide quickly and reversed back into this one because I think the slide itself is enigmatic of open source versus closed source. You can see that I didn't make the slide myself. I started off and I realized, man, I'll never finish this slide set, right? And I looked around for something and I found a wonderful slide by Eraserhead 1. And the only thing he asked for was that I say, it was made by Eraserhead 1, right? I searched and searched and searched and could find nothing that didn't want me to log in, accept cookies, sign up for a marketing thing, join a course, pay something, subscribe to something. I couldn't find it. Couldn't find it. Sorry, couldn't find it. I'll have to practice my beatbox. So, we don't have time for the deep dive. Probably don't have time for the dive. And most of you already know this. Anybody that's been in the Linux, Unix, CPM world? Any CPMers? No? My first company that I joined, that was their programming operating system, CPM, and basic programming. I think if we focus on the left-hand side, where we came down to Linux, if I were to take Linux and the start of Linux and put that in the middle, remove this slide and start again, the explosion would be just astronomical, of Big Bang proportions. But looking back at the history of it, I pinpoint, and we have a color-coded there, thanks to Eraserhead, for open source, mixed and shared source. Before, we had open source, where people put things up on GitHub or make it available. There was shared source, where you could actually, if you applied for it, you could get a copy from the universities or something like that. And that was the case with the early BSDs. Okay? And then we had open source as it moved on, and mostly starting with the GNU projects. And now the slide that I painstakingly had to make myself, and which is probably inaccurate. And we won't go into the details of it all because we don't have time. And I'm looking to my time man. 5 minutes left. It all started perhaps with CPM and digital research, which went on to produce DRDOS and various versions of that. But they sold, produced QDOS, which became 86DOS, and morphed into PC-DOS. And yeah, about the 84 or so, we had the beginning of Novell and NetWare IPX. And I put that, personally, as the start of the NOS system. It was closed, right? And it wasn't, at the start, it really wasn't an operating system, but it was a platform of drivers that integrated with PCs and anything that it could integrate with. Okay. Moving on up along to Windows, took over the desktop market and moved on till they were 95%, I think, at one stage of the desktop market. And maybe they still are today. I doubt that Apple has won over much with theirs. I don't know what the stats are now, but the significant stat is that 70% of the world is now controlled, the mobile world at least, and the mobile now is a mixed, evolved metaphor for tablets and everything else that goes with it, is Android, okay? But sticking to our focus, I put the start of NOS really being NetBSD. But again, an argument to be had over several beers, right? And really where NOS began to flourish was with Microsoft, the most unlikely of all contributors to actually open source a start of a really good network operating system. My first 100% compatible IBM portable from Nixdorf in Germany. I put this up, one, to show you how heavy they were and how strong you had to be to actually carry it around. 14 kilos, the coolest thermodrucker in the world, up on top. But I put it up because disaggregation started in the hardware, perhaps before software, right? If you look at the word, it was IBM compatible. IBM actually published the driver code in assembly for their very early system. And I think it was a 4 megahertz 8088. And people could build IBM compatibles, right? They released the design. So hardware aggregation started beforehand, and then there was a flourishing of various DOS disk operating systems. Actually, I don't know, QDOS, can I point? Pump? No, I can't. Point? No, I can't. QDOS stands for Quick and Dirty Operating System, okay? And that was one of the early forms of it, just coming out of CPM Digital Research, I think. Over on the right, my first Unix system, not that I had personally, but that I installed to one of the first customers in Europe. And yeah, that was a Unix 5 system. Oh yeah, Bell Labs Unix 5. Super system, 300 million, or 3 million instructions per second, 1 gig of hard disk, weighing in at, I think it was 140 kilos, but I really can't remember. So, what is Sonic? Software for open networking in the cloud. It's open source by Microsoft, based on Debian Linux, and runs on switches from multiple vendors. The number of vendors at the beginning was very small, and now it's increased and increasing rapidly. Sonic offers a full suite of network functionality, like BGP, the whole FRR suite, all of varying implementations of what's in that, and RDMA and that have been production hardened yet in data centers of some of the largest, and Azure being one of the largest at the time, but now used by others as well. Okay. It offers teams the flexibility to create network solutions they need while leveraging the collective strength of a large ecosystem. You can get started anytime you want, build your own, download images, prepared images, and run on hardware if you have it, and if you don't let that stop you. You've got several options from GNS, 3, Containerlab, spelling mistake, Containerlab, and QEMU, or the QEMU. Created by Microsoft, not for any altruistic need, but they really wanted to be able to control their own Azure cloud stack, okay? And they realized how much had been done, I think, by the open source community, because it comes straight out of Linux and Debian versions of it, that they felt if they released it out, that they'd get even more contributions and to serve themselves, which was, yeah, that did work. So open sourced in 2016 and handed over to the Linux Foundation, or accepted by the Linux Foundation in 2022. Designed for large-scale data centers with demanding use cases, automation, telemetry, AI, standard-based API. Created to be hardware agnostic and independent from single vendors. So we have today 22 vendors and about 160 plus switching, routing platforms, and new ones being announced daily. Well, weekly maybe, or every OCP summit at least. Okay. It has a modernized container, microservices style approach for GDP, LLDP, SNMP, telemetry, management, a whole lot of aspects and facets of a network operating system. There are commercial enterprise models with 9x5 and 24x7. I say this because that's what we offer. Okay. Free community versions enable full control of all code north of the abstraction interface. I'll do a time check on my guy. I'm done. Okay. I'll move quickly into then. I just have this line at the bottom that I started off as a guide to myself, but I thought I'd leave it. Why did it happen? The main driver was scale, right? The main driver for a network operating system like Sonic was scale. So cloud scale meant many switches and vendors need unified operating system, Sonic. A quick look at the container architecture, and please pull me on time. For the enterprise one, we have at least Broadcom is the main supporter, but new ones like Celestica, and now even Juniper, even Cisco, everyone's, I'll say, jumping on the bandwagon, or at least trying to sonic wash themselves into the community. The main interface between the hardware is the switch abstraction interface, but also you have the switch platform drivers and network platform drivers. Okay. All the containers focus their exchange of information through the Redis database, which is a in-memory database. There is the community version, but it faces many challenges, and a lot of the keynote speakers have focused on this today, in the need for more drive, more pushback into the communities. A lot of the enterprise ones seem to be forking and not returning, or not synchronizing, not pushing upstream, right? Or they are, but it's irregular and it's not synced with their distributions. We recently had a problem with one of our customers, not a problem with one of our customers, a problem with one of our customers' systems. They had a transceiver that wasn't supported anymore, suddenly. And we tried to sync back through the community because we don't have access to, or we don't know exactly which source say, Broadcom or some of the enterprise versions are using. And we tried to sync back, or find our way back through it, and we essentially failed, right? To synchronize where could the change have possibly have happened, so that just like in any of the other open source Linux, we might be able to do a backport or something to save that transceiver. And that is definitely one of the challenges of the community Sonic, okay? So the prime challenge as I see it is as the interface to the ASIC, okay? Because the glue code that supports that SI isn't available. And unless you join with or subscribe to an enterprise version, yeah, you can't predict when you'll get fixes. You will get fixes, right? But it may not come at a time that suits you, and therefore, as usually a commercial enterprise, you can't depend upon it. I think given the time, I'll move quickly on through. And given the guard here at my left, and I'll just move to the last slide. This totally fabricated slide by me. I found too many versions out there to say what the reality is. But the main point being that InfiniBand is being taken over by Ethernet, but only as the AI driver for that is being pushed through. They still haven't gotten over the InfiniBand is still the best from a latency perspective for small packets and small exchanges. And I will move on to where we are now. So I showed you my firsts, and here's my lately. 1.6 terabits, Q1 next year. And yeah, 800 gig 16 port programmable switches for everything that the ASIC won't do for you, okay? And that you want to do something different. I'll go on to simulating, but I won't bother going through it. I quickly went through the 3 possibilities that we know about and we use. We have a workshop tomorrow on GNS3 simulation, and looking forward to seeing as many of you as can fit in the room. Okay, or as allowed.
Thank you.